You don't say, well, I got something better to do, something more interesting to do. And and that's always possible. Anytime in anyone's life, you can always find some things that are more interesting than something that you got to do, right? You can always take these things to the limit, essentially. So you got to somehow look into the future. Yeah, all right, okay. It's crazy, isn't it? You got to look into the future, okay? You got to look into the future and actually figure out, is this really going to help me in 10 years down the line? And am I going to regret not doing something now when I don't have a chance to do it later? Okay, so you have to look forward into the future, and that will actually let you focus more and say, well, I'm going to do this. So you got to explore, and I'm going to give you lots and lots of opportunities. Okay, same thing to online students, right? Dylan, where were the other online students? And you guys have Ian and Eugene. You got to log in too, yeah? Are you logged in? Doing that. All right. All of you log in. Jonah, are you logged in? I think so. Yeah, all right. Your camera is not on. Yeah, you don't have a camera. Brian, you're not. Brian. Oh, you are. Okay. Well, it looks like everybody here is logged. Maybe someone was missing. It looks like someone is missing. Is it Spencer? Yeah, Spencer, you're not on camera. Okay. Yeah. Okay. Great. All right. Excellent. All right. So that's basically it. So here's what we're planning. Yeah. Next week, I think week 6, Thursday, no class. You got to take the exam from home. Any library, STEM center, anything that's most convenient. What I've discouraged people from doing in the past is don't take it on an iPad, in a train, or a bus. Okay, anywhere that internet is flaky, Canvas does weird things. If you drop the connection, sometimes you won't get a chance to revisit that question or even the entire test, and it's a real pain to go back and correct these things. And then you'll get an entirely new set of questions, right? If you retake the midterm, it's just going to pick from my question bank. And I've been adding questions, deleting questions, and there's a whole bunch of things that you can get that you have. So you want to, if you want to, you can do a retake if that kind of situation. Okay, if you have a dropped connection and all. So next Thursday. Yeah, so this Thursday we'll have class. Apparently it's not raining this Thursday, so we'll have class in here. And next Tuesday, I usually give students an option. Okay, so if people want to have a class, we will have a class. Otherwise, what I say is to take the day and review for the Thursday midterm, like 2 days later. Review on your own, maybe have an online meeting. I'm happy to attend the meeting, but it's got to be review of the material, conceptual questions. And on the Reddit, maybe post a question, or even some code like Jonah or Vivian, post it there and say, well, here's a code, random code from some reading material I found on the internet. Yeah. And it kind of uses arrays and reference parameters, which we're going to do today, right? And I thought we'll try and do this, right? And maybe it's not even a game. Maybe it's a program that does some heavy duty mortgage calculations, whatever it is. So you could try and do programs of your own, and you can share that code. Share the code on online GDB and share the link on Reddit, or you can just put the code in the Reddit post. But when you put it on the Reddit post, make sure it is in the right, what is it called? It's that text formatting thing. It's called code style. It's code block style or something like that. That'll make sure your code is, formatted nicely, just like code in Reddit. Okay, just ask me. If you have a whole bunch of code to post, just ask one of us. Okay, Chris, me, anyone. Say, hey, I got some code to post. How do I do it? And we'll be glad to show you. Just don't paste the whole thing. It makes it a big mess. That's all. Okay. So share your own code, and it'll be a great deal of fun. And I want to see this. Okay. I want to see this. And as a teacher, I want to see people jazzed up about the subject. So please do take these projects to the next level. Okay. Today, whatever we're going to do today, it has like scope for, huge opportunities for changes. Okay, so what we're going to do today, we're going to recap, and in the meantime, whoever is going to code today, who's going to code today? Brian, you want to code today? That'll keep you awake, all right, for sure. So yeah, why don't you code today? All right, okay. All right, so Brian is going to code today. So Brian is going to share the screen, and Sahil, switch on your camera. All right, yeah, Krishav, thank you. It's kind of cool, right? Now we don't have backlight. Oh, you know what happens when someone opens chat window? That white strip in a chat window creates so much backlight that it affects the luminosity here, right? Let's experiment a bit. Okay, so let's see. Oh, thank you. Thank you for reminding me. Okay. But not that anybody watches these videos, right? I put them online for the online students, really, right? But the online students are here. And really, we shouldn't be putting them online if you think about it, because if the students don't show up to these lectures, too bad, okay? So that'll actually force people to come to these lectures. So maybe, I'll record these and not share them online until more of these people start showing up to these lectures. And actually show, anyway, it wasn't the chat window. Maybe it was a different thing. There's too much black, white backlight. Yeah. Okay. All right. Maybe this actually works much better. That's nicer. And also the keyboard is now, it's more comfortably placed for me, for standing work, because here I had to do this like that. And so this is much better. It doesn't matter if the mouse is there. Great. All right. So in the midterm, midterm is all objective style, and it is going to be like super cool if you know the concepts, and the concepts will be drilled into by the time you're done with the quests. You'll be using all of those concepts yourself, right? And you'll be bidden so many times that the midterm questions, even though they're not about quests, they're about concepts. But these are concepts you would have actually used, not just had book knowledge. Yeah, if you have book knowledge, you got to remember before the exam, because you could lose it. So no, book knowledge is not what we're going for, right? So you just use the book knowledge to do something and figure out, all right, now I can tweak it here, tweak it there, that take the limit of the book knowledge, because the book only introduces that thing, right? But you got to look around it. And so playing around with the code, it is not a fun thing to do if it is with just some piece of code. However, that's why we got this quest system, so that now you actually just playing around gives you some rewards. So you do various things, which may not be necessary in certain environments, but it will allow you to exercise those muscles to say, all right, if I had to do that in a different situation, this is what I would do. This is the kind of loop I would use because, right, it reduces a problem downstream. Or, yeah.
Would it be like quest-like problems where you have
to
create, it'll be
multiple choice? Yeah, objective style. Did you take the because the syllabus quiz is different, right? It's the same, same as a syllabus quiz, except it'll have programming questions. Does that make sense? Because in the syllabus quiz, yes. So true, false, fill in the blanks, multiple choices. That's the hardest, because each one you got to get all of them, right? So yeah, check all that apply. Those kinds of things. Anything that can be marked by an automaton, I have to review. That's okay, because tests, I don't get a great kick out of reviewing test material. I get it. I actually enjoy looking at your code, by the way, because and it's even more fun for me because I don't have to wait until a freeze date to look at your code, really. Right? Because in the past, I had to wait until all the students submit the assignments, then I can take a look to say, all right, let's see what people have done. Yeah. But now, anytime I want to know what the latest lay of the land is as far as question number 3 is, I just go in there and see what people have been submitting. And I actually review all of your code, right? And it's a great deal. It's very tempting to say, all right, don't do it. But but you got to resist the temptation, right? And I think you were trained to do that as a teacher and as a parent, and to just not solve problems. And just watch them unfold right in front of your eyes, because at the end of the day, you're going to be a whole lot more better, better programmers, and so that's why I told my 2B, or maybe I just told you guys, right? Yeah. So at the end of the day, that's what you should aim for. Always aim for being the best programmer you can. You don't have to be a professional programmer, but being the best programmer you can gets you that into the correct problem solving mind, the expanded problem solving mindset, rather than just seeking analytical solutions. All right. Okay, great. So Justin, you're late, and Matthew, you guys should also switch on your cameras. Let's start. Okay, so Brian is going to share his screen, and then what we're going to do is just go to the Reddit post, and it was because I know that code that we wrote the other day, Spencer, was you, right? Oh, maybe Jonah. Where's Jonah? Yeah, he's over there. You did the other half the other day, right? So the code that he wrote, yeah.
Which program?
That average thing, average guessing.
Oh yeah.
Yeah. All right. So what is this? Why is it not closing just the chat? Okay, this thing. Oh, that's better. It's kind of getting in my eye. That huge bright thing over there, even though it's in the back, that's much better. It feels much nicer. Okay, great. Yeah. Hey, Brian, whenever you're ready, okay, take the screen and we're going to go and just grab that, a bunch of comments. It's basically, that's all we did. We didn't put any code in there. We just put in a bunch of comments. I'll just flesh it out today. Now, along the way, in the process of fleshing out the code, we'll do some cool things, okay? In fact, this week we're supposed to talk about functions, okay? And hopefully later on Thursday, I'll talk about the behind the scenes of functions, okay? What happens actually when you do a function call, all the way down to the CPU. Like super duper important to know. Because did we talk about this before? Call stack, and where we'll talk about this one more time, return addresses and so on, but it'll make a whole lot more sense in the context of a function. Because when we're dealing with functions, you're going to be talking about parameters to functions and the order in which they are and what names are. They will all make a whole lot more sense when you see how a function is being invoked, right? First, you push the return address where you need to come back to. Then you push all the parameters one by one, and that is why it's super duper important in C++, which we're going to be doing very soon, that our function signatures need to be bulletproof and correct, right? You can't say this is a function that takes an integer first and then a character string, and then when you call it, you can give it a character string and an integer, right? Because they're different sizes. Yes. So and why does it matter? It matters because everything goes on the stack when a function is called, and it would push an integer and then a string, but that would pop an integer and then a string, and so it'll only pop, and everything is messed up. That's why corruption happens. And fortunately, these days, when I learned C++, compilers, I don't know if they actually warned you about these things, but you could get into serious issues. Just doing that, or maybe the Microsoft compiler did have that thing. But anyway, getting the types right is like super duper important, because that only matches up the pushes with the pops on the stack. We haven't implemented a stack yet, but Thursday we'll talk more about it. Okay, so it'll all make I'm kind of eager, and I don't want to. I want to start talking about it sooner and sooner. Dismiss the blue and then the white also. So we'll have a bigger screen. Right? Yeah, dismiss the blue part. I think that less than sign on the side of the blue. Yeah. No, you see that less than sign in the blue ribbon on the left side, blue ribbon. Yeah. Click that. Okay, and then I think, yeah. How do you minimize the console? Because we don't need that right now.
Professor?
Great. Okay, so this is what we're going to do. All right. So essentially, is that the very top? No, that's line 18. Just go right to the top. Yeah. Okay. Right. So we're just going to do that. Yeah, get rid of that online GDB thing. Right. We don't need that. Okay. All right. How about this? Do you want me to code this, or I can just gently guide you through this? Okay, because it's all very straightforward. And in fact, Brian, what we'll do is that you can either type it in yourself if you want, okay, or okay, wait for anyone in this group to just call out. Okay, it shouldn't just be me all the time. Someone's scribbling with red ink.
Professor?
Yeah. Oh, someone's trying to grab my attention.
So where do you post these lectures? Because I know some of the online peers like me, because I have online, we can't always make it on the lectures, because right now I just arrived home from the train and the train comes late, so I can't always make it to the lectures, because right now I just came from the train.
Yeah, all right. Anyway, try to make it to as many as possible. Hey, how come it's so bright around where you are? It's kind of dark here in Los Altos. It's like, it's like afternoon or evening for you.
It's a Cal train, because I live in San Jose.
Wow. So it looks like it's, it's still late afternoon for you. Anyway, yeah, that's fine. It's on YouTube. Just post, ask in the Reddit. Ask in the Reddit. You know where the Reddit is, right?
Yeah, I'll ask in the Reddit, because you were saying like you're not gonna post it anymore, so people come to lectures. A lot of people don't.
So all right, I'll post it. Okay. Yeah, I'll post it.
Thank you so much.
But the point I was trying to make was nobody actually sees these. When I log into the console of the studio, the number of views are like 0 or 1. Most of the time. I say, well, why do I even bother putting these videos up if nobody's being helped by them? So yeah, if you guys watch the video, that's okay. All right.
Okay.
But certainly,
Thank you.
I think it's well, yeah, it is lecture material. It's it's owned by the taxpayer ultimately, because it's part of the salary that Foothill pays me and everything. So this material, the content that's being created, really belongs to you guys. It belongs to the taxpayer for public good. So I think we just put it out there in the open. Yeah. So yeah, it doesn't belong to me. On the other hand, I think the LOSIF notes are actually belong to the school. They paid some money for it, I'm told. Okay, just to be on the safe side, don't quote or cite this in the forums or in public talk, or the LOSIF materials. Yeah, there's lots of material. There's lots of other alternatives. Yeah, in fact, LOSIF also selected topics from the book, essentially. Yeah, and I'm going to take references out and then point directly to the book or other sources. Actually, in our spec, we don't have any references really. We don't refer to anything except to interesting footnotes and saying that story and so on. Where do we have referred to anything at all? Yeah, I think in the modules we refer to stuff. So, but when we say the modules are just optional, if you find them unofficially at the CS Club, you can use it. Yeah, well, there's nothing to prevent people from using stuff on it, but they're not going to be. All right, Sahil. We'll put it online, okay? So you can take a, yeah, you can.
Thank you.
Right, no worries.
Bye-bye.
Okay, bye. So here's what we're going to do. So get rid of that intentionally left blank and develop your own version of this. Now that we know it's not happening. All right. So let's go and flesh it out ourselves. Okay. So what's the first thing that we are going to do here? Let's see. Here's the overall plan. And what we're going to do is together, we're just going to refine the plan before we do the whole thing. Okay. So here's in our main, we are going to have a vector of 10 numbers. Okay. 10 integers. And they're ints. Should they be ints? Actually, yeah. Let's make them all size t, because it's harder to average when negative numbers are involved. Yeah. So we'll just say they're all size t and they're going to be positive numbers. And so the first thing you got to do is fill the 10 elements of the vector with 10 random integers between 0 and 1,000. Can you guys do it? Okay, that's the first task. We don't have to do any more than that. Okay, so I'm just going to say it's task by task, and every one of you is going to take your own, take a crack at it. And if you are going to call out the code, then Brian will type it. Otherwise, he's going to, either not do anything or type your own. Right? You have the choice. Either don't do anything at all, and just wait for someone to say, "Can you type it in?" Right? Otherwise, if you feel adventurous, you can go ahead and say, "You got the keyboard." All right. Or at least it'll make sure that you don't feel sleepy. Is that good though?
Yeah.
Yeah. All right. Okay. Great. Okay. Excellent. All right. So here's what we're going to do. The first step. All right. So let's just put the first step there. Well, indent in and put a comment. Indent in and put a comment. And I'll also create the vector for you. Okay. We're going to create the vector. Oh, by the way, hash includes. It's not hash include rand. Okay. All right. So we're going to do the comment first. Do the comment. Yeah. Do the comment. And the comment is going to be. Fill the vector with 10 random integers, positive integers, right? Non-negative integers, not size t integers. Just say size t. That's much better. 10 size t integers. Yeah, 10 random size t integers between 0 and 1,000. Right? Doesn't matter if it's inclusive, exclusive, doesn't matter. They're all going to be random. Yeah. Right. So 0 and 1,000. And you got to do this. And someone call out the code, and it's just going to be a for loop. But before this, I'm going to declare the vector for you. Okay. Because the vector is something that we did last class. So go to line number 37 and hit enter. Go to line number 37 and hit enter. Okay. No, not there. Get rid of the blank lines. Yeah. Inside, right. And get rid of the blank line above that too. Great. Okay. So enter. All right. So now you're going to create a vector. Okay. So you're going to say vector, and then immediately less than, right? That's the angle bracket left, right? And then say string, size t inside of that, because we need a vector, an array of integers, right? Size t, guys, not strings anymore, right? Not anymore. In this thing, we're not using a vector of strings. We're using a vector of integers, right? Basically a vector of size t. Raj, you got a puzzled look on your face.
Yeah, why would you just do Use an array.
We could totally use an array. Yes, yes, thank you. All right, so here's what we will do. If we were using an array, this is what we'd do. And that is exactly what Raj said. So cancel this out, right? Get rid of the 37 and so on, right? All right, so if let's use a native array here. And let's say size t space, let's say rands, right? Random ints, square bracket 10. Okay. And let's not put a comment saying what it is, because it is what it is. And but we'll just speak it out. Okay. So, and everybody should say if you understand this or not, right? What this does is that it tells the compiler to set apart how big is size t, by the way. Yeah, how big is it? What is the size of size t? How many bytes is it? Actually, it's 32, right? It's actually, I think it is 32, isn't it? You know how to find out? All right, just open another tab. Just hit another tab, right? Hit another tab.
It is 30.
No. Oh, what did I say, by the way? 32 bits, 32 bits, 32 bits. I'm sorry, 32 bits. But open another tab, Brian, right? And where you have the, oh, this is another tab, and you copied the whole thing, and go to online GDB. And where's the cout? Just say size of size t. Instead of printf hello world, you can get rid of the whole thing. And oh, they got a printf. Just get rid of that. Get rid of the line 13. No, just line 13. Triple click on that and say cout left shift. Cout left shift. Size off is a compiler directive. Okay, it is actually a compiler directive. Size off, right? Open parentheses, and inside you can say any type that you want. Okay, it could be size t, it could be int, char. It'll tell you exactly how big it is. Okay, size t, right? And that's how big size t is. Well, you can actually read the documentation and find out, but this is a fun way to find out. All right, so you need an endl, otherwise it won't flush. Okay, you have to put an endl after that. If you run it, it'll basically tell you how big size t is. It reminds me of this joke, right? When I was a kid, like, far younger than you guys, when I was in, the 7th grade or something, my neighbor in class told me this joke and said, how do you find the height of a building using a barometer? Okay. And apparently there's many answers to this. And one of them is, take it to the top and measure the pressure, take it to the bottom, measure the pressure. And the manual tells you what the pressure differential should be and find out and all. And there's lots of answers. Okay. And lower the string and measure the length of the string. But apparently, so the prize winning answer he told me, and I still remember, his name was Kishore. Was that the best answer was find the janitor of the building and tell him, I'll give you this really nice barometer if you tell me how tall this building is. So you can always refer to the documentation and it'll tell you. But sometimes it's more fun to tie a string to the barometer and lower it from the terrace, right? So that's basically what we're doing here. So it says 8. Wow, it's 8 bytes. All right. So on this machine, which is a Docker instance, most likely. Yeah, Chris? Yeah, somewhere in the cloud. Online GDB, they are running it on a blade that gives 8 bytes. That is like as big as a double, 8 bytes to store a long integer. That means you can go from 2 to the you can go all the way up to 2 to the and it's all positive, right? 0 to 2 to the 8 times 8, 64. 2 to the 64 minus 1. Okay, 0 to 2 to the 64 minus 1. That's a pretty large number. Yeah, 2 to the 64 minus 1 is a large number. It's basically it's 4 billion times 4 billion, and so that would be 16 billion. So 16 quadrillion. Yeah. So that and it's size t. So you go from 0 to 16 quadrillion. But if the same thing was integer, if you change that size t to int, it'll tell you it's still 8 bytes, right? Change the size t to an int. I think it's still 8 bytes, not 4 bytes. Oh, maybe it's 4 bytes. Oh, it is. It says 4. Oh, okay. So int and then long. Okay. Yeah, size t is long. It makes sense. But still, I'm used to the generation where ints are like 2 bytes unless you ask for 4 bytes, and long is 4 bytes. And 4 goes, from 0 to 32K. It helps to know, even if you don't use this these days, most of these Macs are like 8 bytes and so on. Hey, that explains everything about size t. Yes. And so here, go back to the other tab. You can hear, control W or command W. Yeah. Right. So here, so what this line does essentially is ask the compiler to give it 10 times 8, because size t is 8, 80 bytes in memory. However, these 80 bytes or what is used by vector. Okay, the vector uses a different kind of memory than using a native array like this. And you don't have to understand the guts of it right now, but it'll make total sense later on. Okay, when you declare it like this memory is on the stack right here. But when you use a vector and say 10, right, that memory has to go through the memory manager to the heap. We're going to have terabytes of memory, and obviously fetching memory from a bigger pile incurs more energy, essentially, isn't it? It's slightly more wasteful. Slightly, not even noticeably, because they're both O of 1. What are they? Constant time access. Bam, bam, like that. Except that it is bam and it is bam. Right? So they're both slightly smaller. And so whenever possible, use the stack, because stack just comes and goes. There's no management involved. You don't have to get it and then release it, and you don't have to go through the access like that. I think that's what it is. Okay, you have to check this with whoever you're doing a computer architecture with. I don't know. Are you enrolled in CS2A? Oh, and maybe you guys are not, but whoever is teaching CS2A, you can check with them to look at the access times for heap versus stack and see if they're different now in the new architectures. Maybe I'm totally wrong or out of date now, right? So all right, so this is what it does. We're going to have a vector, a native array of 10 bytes. And this is the fastest you can ever get. And there are, other than variables in registers, this is as good as it gets, really, right? So put a semicolon there, right? And say on the previous line, let's put a comment, right? Put a comment, right? The following line gives us 80 bytes in memory, okay? 80 bytes in memory. The starting address equals random_ints. Does that make sense? I think that's a good enough comment for summarizing what the following line does, right? The following line, it says, give me 80 bytes of memory, and the first byte starts at this address who's stored, it is random bytes. So random bytes of 0 is the first byte, for first 8 bytes, right? Random bytes of 1 is the second 8 bytes, byte number, whatever that is, plus 9 to 17, 9 to 15. Yeah, and it goes like that. So 8 bytes in chunks like that, and they're all contiguous. Does everybody have a clear picture of what a native array is? I'm actually glad that, thank you, Raj, that we used a native array, because I wanted to talk about native arrays at some point, but this was a fantastic way to use it instead of a vector. Now, but everybody understand the difference between a vector and a native array? It's like super duper important. Not super duper important, but it is very subtle. But it has to be appreciated that, one of that is, it is not noticeably, but it is appreciably faster than the other, even though people just say, it's O of 1, who cares? Okay, so whenever possible, we do it this way, right? I think. All right. So now put a blank line after 38. Blank line after 30. All right. Now this part, fill the array, right? Fill the array. It is change the word vector. Change the word vector. Yeah. Into fill the array, comma, space, random_ints, square bracket, 0.9. 0. So is that Python notation? 0.9 or something like that? That says all of the indices between 0 and 9. So that has been given to us. Yeah. Is there someone in class?
No,
All right. Okay. All right. Okay. So so that is being given to us. Hey, who drew these red lines on the page? It's been there for a long time. Is it possible in Canvas? Is it me? No, it's not me. Someone's playing around. Okay, anyway, it's not interfering with the code. Doesn't matter. It's not interfering with the code. Okay, all right. So all right, now let's clean up the thing. All right. So get rid of hash include rand. We don't have hash include rand. There's nothing called rand. However, change that. Change it to hash include cstdlib, right? That is a C standard library. All right, close it. And then we got using namespace standard. We're using native array, so we don't need vector. Okay, all right, and delete. Yeah, delete the blank lines and delete the blank line. No. You can have, yeah, all right, that's fine. Split it up how you like, and then yeah, get rid of the blank. There you go. All right, okay, all right. Now this part is the bit that I would prefer. If you guys can do 5 minutes, not more than 5, and all you have to do is loop from 0 to 10, pick a random number between 0 and something like that. Well, you can do srand, okay? So right at the top, after 30, after line 30, hit enter. Yeah, and who remembers the idiom for srand? Anybody remember what the idiom is? How do you srand at the beginning so that rand gives you different randoms every time? Nobody remembers? All right. Hey, Jonah, just call it out and then Brian will type it in, okay? Oh, how are you guys online? Okay, online, all you guys, okay? Hey, Brian, really cool lighting in your home. What is that? You know, LED? Can't even see. Oh, yeah, really cool. What is, do you remember? Okay, I'll tell you what it is. Don't worry. Don't bother searching. Okay, srand, open parentheses, and then you want to cast it. You want to cast it to unsigned, right? Yeah. Right, except two parentheses before unsigned, because we're going to close one of them and we still want to be inside parentheses. No, not quote. No. Two parentheses, not double quote. Yeah, unsigned in there. And then outside the first set of parentheses, outside. Yeah, that's right. Outside. Yeah. Space. Time. Right? Open parentheses. Pass null pointer as a parameter. Okay. So you got to memorize this. You got to memorize this if you're doing things that are, you know, supposed to be interesting, meaning that you want a different sequence of randoms. Even if you're doing statistics and you want to run a Monte Carlo simulation or something like that, right? Which generates lots and lots of random examples. You got to know how to seed these things. Yeah. Now, different ways to seed. This is the simplest. If you're actually using a random, there is some in C++ later on, you'll figure out how to use something called a random class. Okay. It has many different distributions inside of it. This one only has uniform and it's all integers, right? But you can actually get a random class, which can give you a gamma distribution, you know, something like that, you know, a really fancy distribution, exponential distribution. And you can say, give me numbers that match this, a Gaussian normal curve. And you'll get random numbers that match that. And you get more numbers in this. Right now, if I graph all of that, if I graph the frequencies of all of the numbers I'm getting out of rand, you'll see that it's all, you know, horizontal, like a rectangle. We did that in one of the past classes. Maybe later on we'll do that because you get lots of randoms and you just have to, you know, bar graph how many times you get numbers in each range, and it'll be like a rectangle because it's uniform. And try and do this on your own. It's like super duper important, right? It's hard. Generating uniform randoms is not an easy piece of cake, okay? Because as humans, anything we do has got some kind of a bell-shaped curve to it, because it's the sum of many random phenomena. When you add many things together, the central limit theorem kicks in, and we find it very hard to generate things that have other than a bell shape, because things add up, you know, standard deviations, and you get this normal curve. So flattening that to get a uniform out of a Gaussian is actually very hard. It's strangely enough, I'd say, you know, in a past life, in a different company and all, we were actually trying to come up with a cheap way to generate a Gaussian, a normal curve from a uniform distribution. This is why we use something called a Box-Muller transformation, which is really cheap. But there's actually cheaper ways to do that. But strangely enough, you know, that's what we were trying to do in order to test something in advertising, some theory. We had to generate Gaussians of a particular distribution, and this is what we used. But the challenge usually is going the other way. How do you get uniform? Uniform is not natural at all, right? It's as unnatural as you can get. So that is why a lot of, hey, welcome Simon, okay? That is why a lot of work has gone into how do you generate good uniform random numbers? And to date, we don't have one, right? So in fact, this rand, if you look at the manual page, it'll say rand gives you a pseudo random number. It doesn't tell you it gives you a random number. It's a pseudo random number. Because even if we get close to that and say, well, we're going to seed this chip of alpha particles from space, cosmic rays, that's probably as random as we can get. Yeah. And that's possible, you know, space station signals beam to us and so on. We can do that. We actually get a real-time counter. If you actually go to one of these government sites, they have many of these web pages where they get real-time feeds from satellites. So I actually had one of these apps, fun things that we did in the cloud course that I ran. We were sampling some data from NOAA and about the proton activity in the ionosphere, which is basically they collect that and publish a chart that updates every 10 seconds. It's out there. It's ASCII, so it's like super duper fast. So we're sampling that and generating musical tones based on the latest proton density. And it actually turned out to be really cool. We actually did that in the cloud class. It's in one of the videos, I think. Take a look at service star songs or something like that. So anyway, so you can get randoms in many different ways, but the beauty of RAND is that they were able to create a process by which they could get uniform from a very, very high degree of randomness in there. Anyway, so the summary of that is SRAND, that line, even though it's so simple and just one line, there's a lot of history behind that, and it's worth diving into. If you have time, do a little research and say, this is why it is, and that's what, what is randomness, and so on. All of those are interesting, not only conversation starters, but also something to beef up your Reddit profile too. Yeah. And say, and it's cool. And also you get points for these things. It's not like you get points for these things too. So you can look up what randomness is and what SRAND does. In fact, SRAND is really key to how we do the quests, because using SRAND is how I control how your tests and my tests behave. Because in quest number 6, you're going to be getting names and generating random names. How do I make sure your random names are the same as my random names? They're random, yes, but they're random, predictably random. This is an oxymoron. If there was anything like an oxymoron, predictably random, right? They're random for you, they're random for me, but together they're not random. So and we can do that using SRAND. Okay, so all right, we're putting Brian back to sleep. Okay, put a semicolon and hit enter. Okay, all right, and everybody knows what SRAND does. No comment there. Yeah, good. So here's what we're going to do. You're going to do 10. What time is it now? What we'll do is I'm going to go and take a drink of water. What time is it? It's not even showing. Where do I? 6:43. We got time. Okay, we got an hour. How about 5 minutes? Okay, 5 minutes. So how about each of you do your own? Okay, no group work. Okay, even though you're all like close together and all, it'll be don't be biased by even looking partially at what someone else is. Because otherwise you have different flavors. Then it'll be nice. So what? I don't know how much you can do, but if you want to do more after that, that's fine, right? So the next thing we want to do after doing that, well, in case you're done with that quickly, let me tell you, right? In case what do you want to do? All right, fill the randoms with integers. All right, now the second thing you want to do is calculate the average. Okay, just say and the average has got to be double or float, because the average may be fractional. Yes. Okay, so you're going to declare a float or a double, doesn't matter which, is equal to the average of those 10 numbers. And there you got to bring a lot of what you've learned in CS2A into bearing, because you know that, yes, because there's type differences. You got to make sure all the divisions happen in the right space. You can't say, wham, bam, and all the fractional part is lost, but, got truncated. It doesn't work. So you got to make sure that you got the correct average, and you do it in a loop. So it's two things: fill it with numbers, randoms. Second, get the average calculated. Okay, so that's saved. 2 steps. Do we need to do anything more? You got the average. After you got the average, you know what? I thought we should probably change the 3 and 4 slightly. What we should do is, no, hang on. Look through the players, ask each one to enter the guess. Yeah, okay. Here's what we can do. Now, just get the player names and their guesses at the same time. You don't have to go through the 2 loops again, right? So what you want to do is get in a loop. Everybody say if you're okay with this. Okay, all the guys online. Let me increase the size of your, this thing here so that we get more of you. Is that all? Okay. Akash, you're online? I didn't see you until now. Okay. All right. So what was I saying? Yeah. So you get in the loop after the 2 steps that I described. Maybe you'll be done with that in 10 minutes. After that, if you're still looking for things to do, this is the 3rd thing. Can you guys remember, or do I need to write this in here? Right, and get rid of all the comments, because we're going to do it. I'll leave it there. We'll get rid of it later. Right. So here's what we're going to do. Get in the loop. You're going to say enter player name. Okay. Everybody, give me a thumbs up or something, because I can leave you thinking that, well, you can do it later. Right. Not now. Right. First thing, you're going to say enter player name. If they just didn't hit blank, bam, like that, enter, meaning the name was empty string. Okay. If you got an empty string, that's it. No more players. If you didn't, let's say they said John, and hit enter. Okay. Very next line, you're going to say, hello, John. What do you think the average was? Oh, yeah, yeah. All right. So after you fill, oh, yeah, we got to show the array. All right. Before you get to that, you got to print the array. Okay. And then sleep for 5 seconds. Oh, you got to print a prompt. You got to print the array. Again, you're going to use the same techniques and tricks as you used in quest number 4, where you format the numbers correctly. Yeah. So you're going to set width and all. So make sure that every number is got 4 spaces or something, right? Or 10 spaces, five spaces between them, evenly spaced. You're going to print all of the numbers. Okay. And then say, you better look at them for the next 5 seconds or something like that. All right. See out. And then sleep for 5 seconds. And after that, that's got to go first, and then the numbers, because you need to be on the same line, /r and flush. I don't know if, I'm saying all this because we've already done it once, but if it's just, if you've forgotten everything and what I'm saying does not make sense, you should tell me. What you want to do is print the prompt. Okay. And after you print the prompt, you want to print the 10 numbers, nicely formatted. Any of this not clear, you got to tell me. And then you're going to print, and you're going to sleep for 5 seconds. Someone's trying to say something? Matthew, was that you? I'm going to continue, okay? I thought someone was trying to say something.
Not
Hayden,
me.
you should switch on your camera. Matthew, what's up? No, you good? You good? Right. So can you, someone repeat the steps after me? So the first thing you got to do is fill in with 10 numbers. The second, calculate the average. Why don't I put it there? I'm talking about this like 100 times. I'm just put it there in comments. This is what you got to do. All right. So, and you can do as many of these as you want. Okay. So, all right, go to line 35, hit enter, and you're going to pick things off and do them one at a time until I come back. All right. So first comment, right? Number one. And we're going to say, calculate the average into a float variable. Everybody okay with this online? Yeah. Can we go on to the next step? Number two, right? And what do you do after you calculate the average? Let's see, we had one more step. Oh, no. Number one, this is number two. What you had, that was number two. We need one more before that. We need one more, right? So maybe we make number zero before that. Yeah. Right. 0, and that's going to be fill random ints with 10 random integers. Fill random ints, random underscore ints, with 10 random integers from 0 to 999. This is it feels like we did this already. Yeah, this is line 39. We should have cut and pasted there. That's fine. Okay. All right. That's number one. Okay. So put number one. Yeah, that's 0. And number one is calculate the average into a float variable, and call it a comma AVG. Right. Give it a name so that you're not wasting time finding names for these things. Right. Yeah. Comma AVG. Yeah. And say float AVG so that people know it's a float. It's not a float AVG. All right. Okay. Right. On the next line, you want to say after you've calculated the float variable. All right. Now, yeah. No. Number 3. Number 2. What is it? 0, 1, 2. Number two. And by the way, you can get rid of 39. We're not using that, right? Because we've already said that. Triple click and delete. Yeah. Triple. Right. So, and number 2, after you calculate the average, right now, yeah, print a prompt saying, take a good look for the next 5 seconds, and take a good look for the next 5 seconds. Take a good look at the line below for the next 5 seconds, right? Print this, right? No, you don't, not after you want to just say print a message, colon, something like, okay, it doesn't have to be exactly this. Take a good look at the numbers on the next line for 5 seconds. ... Right? For the next, yeah, 5 seconds. Something like that. Okay. ... Right? Now print all of the numbers nicely formatted, all the 10 numbers nicely formatted in one line, and end it with a /r, then and then call cout.flush. Now, after we've got this working, here's what we're going to do. We're going to take bits of this and move them into functions. Okay. We'll take parts, we're going to do everything in main right now. And then we're going to move them into function. And in the process of moving them into functions, which may not happen today, maybe it'll happen on Thursday. Yeah. We'll say we're going to take this function that Brian wrote, and we're going to decompose that, and take this part and put it into a function. This part doesn't. So main will only consist of function calls, and functions will do all the bits. Yeah. And we've got to pass parameters to these functions. And now you'll know, once you know that the whole thing is in main now, this is the logic we're working on, or this is what works, then you'll know, oh, I'm going to take that and, this is how functions work, because, I know how this works, and the same thing is working with functions, and this is how I broke it up. And I think that is the best way to learn about functions, okay? And also how parameters are passed. And I've thought about how we can work in different ways of parameter passing, right? Passing by copy and passing by reference. This is like super important topics in functions, and they're going to be tested in the midterm. And there's a lot of emphasis on that. It's in week 5. And we're going to be talking about functions and different ways of calling functions, parameters. It's all in the midterm. So, and we'll do that. We'll do that today and Thursday. Yeah, we'll have a class on Thursday, right? It's only next Tuesday it's review. Well, we can have a class on Tuesday too, if it's not raining. Yeah. All right, nicely formatted in one line, end with a /r, end with a /r, end with a /r. No, backslash. Someone else also made the same mistake, or maybe Jonah. You put a / instead of backslash. Very common in CS2A, right? When I say /r, people always say /, because that's what comes first to our mind, right? Backslash, right? And then after that, comma, and do a cout.flush. Okay, that's like super important, because if you don't do a cout.flush, the numbers don't appear. Yeah, all right. Cout.flush. All right, open close because it's a function call. All right, so on the next line, you're going to say, on number 4, you're going to sleep for 5 seconds and then print a lot of spaces, erasing those numbers, okay? And then an endl, erasing the numbers, and then an endl finally, right? And then an endl. Okay, so number 5 is going to be, all right. You can tidy this up later, okay? Enter player name, okay? Enter player name. All right, no. Do a loop in which. Now this part maybe I'll have to come back for, but you can absolutely take a crack at it yourself, okay? So and then in which, and then colon, and then let's go inside the loop, right? So colon there, colon, and next line, and this is all part of 5. So just comment and indent into the loop. I'm refreshing out most of the code for you, but it'll be useful. Go into the loop, right? So in which you ask for the player's name. I'm not going to go into the details here. You know how to ask for the name, right? You're going to say, what is your name, colon, and then cn the name into a string variable. Yes? Okay, so everybody's got, all right, good. All right, so ask for the player's name, right? Because you're going to loop into, right, player's name. No, players, not group, right? Players, yeah. Player's name, one. Name, enter. In a loop, you're in a loop. Ask for the player's name. If the name was blank, you break out of the loop. Otherwise, if the name was blank, you break out of the loop. Yeah. You break out of the loop. Otherwise, right, on the next line. Otherwise, on the next line. Oh, I see. You want to put it there? Yeah. Otherwise. Or you can say else is better, right? Because you can actually directly use it in code, right? Else is a keyword. All right, okay. If you break out of the loop, otherwise, else you're going to say, what do you think the and say, dear XYZ, what do you think? What is your estimate of the average? Okay, dear XYZ, what is your estimate of the average? You're going to get an integer input from that. Yeah, not an integer. You're going to get a float input from that. Essentially, what you're going to do is you can either do a cin. Well, we'll get back to this later, okay? Ideally, the best thing to do is to read it in a string, and then it's the same. You got to do the same thing that you did in your quest, but I'll walk you through this, right? If you get stuck, what you have to do is use string stream, right? You're going to accept it into a string, and then you're going to parse a float out of that string. And the reason you got to do it that way is when you accept input from a user, they'll have a trailing new line. at the end when they hit enter, right? Cin will not get the /n. It'll only get what's in front of the /n. And the /n will get read by the next Cin. And you don't want all that mess, okay? So you read the whole thing in and then leave the /n in the string, right? You just read this part into a float. You know, it doesn't, maybe it doesn't make a whole lot of sense now, but when we do that, it'll make total sense. Well, I'll come back to this, okay? Even if it's not today, we'll do this with that part, okay? We can do that on Thursday. But it's very simple and straightforward. You're going to be doing a lot of this, okay? All right. So else you're going to say, dear XYZ, what do you think is the average? Yeah, and then read in their guess, into a float variable, right? Into a float variable. Okay. Now here's what we're going to do. All right. Now do we have a random ints? I see we have random ints. You know, we have to use a vector as well. You know, we can technically get away. No, for this, we're going to use a native array. We got to use another thing. We got to have a vector of an array of players and an array of scores also, I think. And do we need to store it? Actually, you know what? All right, here's a challenge, okay? And it's like super duper extra credit if you can do it. Now, we're going to do it using two arrays in class. An array of player names, which you get from here, a parallel array of their guesses. So in other words, you have an array of strings saying Rebecca, Kiera, Spencer, Chris, right? Roger and all. And then parallel, right? Zero, Rebecca 0 at index 0, Rebecca's guess is a float at index 0 in a parallel vector. So two vectors side by side corresponding to each other. Now we can do a lot with this. It is possible to play this game without using those two vectors, okay? So you have to modify the logic slightly. If you do that, I'll give you extra credit, okay? Meaning that you already know the average and you're cycling through the vectors. You get the player and the guess, and you already know what the average is. And you should be able to make the decision in real time without having to store that. In other words, you have, yeah, please tell me if any of you find this confusing. We're not going to do this, but I will give you extra credit if you do it, okay? Here's what we're going to do. We know the average. All of you guys, okay? Rebecca, you're tired? You're sleepy? All right, good. All right, okay. All right, so you know the average, and you got the player name and their guess. Now, you should have two variables somewhere, two variables, not arrays, right? Best guess player name, two variables, string and an integer, okay? And you should be able to tell at any time if a guess is better than the best you already have without having to store it anywhere. Yes? So when you cycle through all of the players, at the end, you're guaranteed to know the best player, the best guess, the closest to the actual guess, as well as, yes, I think so, yes. The average, and then you calculate the difference, and then the least difference. You're going to basically store the player name with the least difference. Yeah. So if you can do that, it is like super duper simple, right? So if you get stuck, we can walk you through this, but you can do this without arrays. But here is what we're going to do. Instead, we're going to read their guess into a float variable. On the next line, you're going to say, on the next line, in, and say, store the player's name in the players vector, okay? The players vector, okay? And you can say players square bracket, yeah, all right. A vector of strings, players vector of string. No, players, into a vector of strings called players. I think that's much better. Okay? In a vector of strings, right? Called players, and yeah, that's fine, right? And then store the corresponding guess in a parallel vector of floats called player guesses. Is that okay? Right? So now you got all of it, and you know how to when to break out of the loop. And when you break out of the loop, what you're going to say is essentially which one of the players is the closest to the actual guess, right? Which you can find out using Spencer's hack from last class. Does everybody understand what Spencer has suggested? Do you remember? Right? How do you find the closest? You got to find the difference and find the least difference. Yes? Well, I shouldn't be the only one talking, right? Is everybody okay with this so far, right? So far, is everybody okay with the steps that I've outlined? Yeah, if you have any questions, you should ask. Okay, I'm going to be walking around, but ideally we should be solving it in a group environment like here. Okay, not individually. But if you're okay with this, you should code, right? So store the corresponding score, the guess, in a parallel vector of floats called player scores. Yeah, player underscore scores, player underscore scores. All right, and I'll declare those two on the top too in main. Yeah, actually after size t ends, yeah, hit enter. After 34, after 34, after 34. Yeah, yeah, we're going to do vector. Okay, no native array here, Raj. Okay, so it's a vector of string, vector square bracket string, square bracket string. No, not square bracket, angle bracket string. Okay, and say player. What do we call it? Players, right? No, angle bracket, not square bracket. Angle. Yeah, the less than. Yeah, string, close, right? And then space players, and semicolon. Yeah, semicolon. Enter, and then vector square bracket float. No, I'm so sorry, Brian. I'm saying square bracket, okay? I mean angle bracket, okay? Angle. Yeah, player underscore scores.
Can we use methods?
Yeah, we can, but let's use it next day on Thursday. Yeah, because essentially what we want to do is develop the whole thing in main and then package off bits of it into methods. No, but actually we're not going to be using methods. We're going to be using functions, okay? Methods will come next, the week after next. Yeah, technically we can start using objects right away, but it just dilute your time into the midterm, because midterm we're not testing you on objects in midterms, right? So until the midterm, we'll just talk about non-object oriented stuff. Essentially just see, right? And then although we're using some of these features, but after that we'll use methods. Okay, until then we'll use functions. Methods are
We're creating our own methods from those functions.
we're going to be here. We're just going to be creating functions. Yeah. However, methods are what are methods? Once you understand functions, methods are nothing but functions that are attached to an object, meaning that it's a regular function, except it gets one more parameter that refers to the item itself. We'll get to all that later, right? When we talk about objects and members and all. But yes, we should ideally, in fact, what we'll do, Roger, is take the same game into week 7, right? And make an object-oriented version of this, and show how you can have a player object, right? And arrays of objects, like you're doing with pet objects, right? Arrays of objects, and hopefully you'll be in quest number 7 then, when we have to actually have arrays of vectors of objects and all. Yeah, so it'll help. So we'll play with this. We'll continue playing with this, okay? So it's going to be important, this GDB link or whatever it is that Brian is working on right now. We'll revisit this continuously because it's got a lot of scope for improvement, right? Not just from me. Even you guys should just fork it off and do independent versions of it. Isidore, yeah, thank you for coming back. Okay. All right. Okay. All right. Enter there. Enter. Yeah. All right. Okay. All right. So now go to the bottom of the comments. Bottom of the comments. Read in. Okay. So all right. Okay. All right. Okay. Now after you break out of the loop, right? Number 6. After you break out of the loop, right? It's a comment in there. 6. Yeah. It's number 6. Now you can advance as many bullets as you want. Okay, you don't have to stop after 1 or 2, right? You can keep on going but before you go on, you can check with your neighbors or even across the table or people online. So can you look over my code? So you're absolutely certain. You can keep on going as many as you want, right? Even on Reddit, you can ask and keep going. Right after you break from the loop. No, in fact, here you would have broken up. Yeah, you should say number 6. Here you would have broken out of the loop, right? Here you would have broken out of the loop. Right here you would have broken out of the loop. Calculate find the best guess. Do I need to elaborate that more? Right, so find the best guess, basically meaning whose guess is the closest to average, right? So find the best guess and the corresponding player. How do you do that? You have a vector of floats. Is everybody okay? You have a vector of floats, let's say 10 numbers and a target. You're going to find out which of those floats is the closest to the target, meaning which one has the least difference. Yes, let's say it's 4. 0, 1, 2, 3, 4. That's the 5th, right? Index 4. That means players of 4 is the name of the player who got that guess. Yes or no? This is the idea of what is called a parallel array, right? Parallel vector. It is one of the most messy solutions in computer science that I've known. Yes, because think about it. There's enormous bookkeeping involved in making sure that these two arrays are aligned. Is this strange thing is, even though we know it's bad, I've actually seen production code in machine learning that munches data together using parallel arrays. And usually it's really bad because it on the part of the programmer, there's a huge amount of cognitive load just to make sure that things are in order, because things could go haywire anytime, right? In questing, you'll be increasingly encountering these broken pointer errors, right? Especially when you're working on green quest, blue 4 and all. There's so many pointers around. And you know that it's really extremely dangerous if you don't keep records really, really carefully. And that is part of what CS computer science really teaches you, is to pay attention to the detail and be resourceful. And be always on the lookout for corner cases and things that could go wrong. So that when you take a step out of your house, right, you know for sure that you're not going to be shot in the head. Means, that kind of thing. You have absolute certainty, because if you think that's any issues, corner edge cases that you've missed, you're not going to venture out until you know for sure that's been sealed off, right? So and that is the kind of attitude you bring to bear on programming eventually, because you'll start looking at code and saying, well, is there any remote possibility that something could go wrong and fry the user's, not even fry the user's computer, right? Because essentially program crashing is the same as your program dead. They delete it from your phone, right? So you got to all right. So anyway, here you would have broken out of the loop. Find the best guess and the corresponding player. Yeah, congratulate them and exit. All right, that's it. Okay, that's it. All right, that's all. Right, number 7. And you can get rid of all of that comment, all of the comments you had at the top. I think they're obsolete now. Right at the top. Right at the top. Now we have all of the steps for this game here, right? And they're all, yeah, Raj, yes.
Is there one step missing where you have to find the difference between
using Spencer's hack?
Yes.
Yes. Did we not hear?
Like, I think it would come. I don't know if it.
No, that's what I meant. Yeah. All right. Okay. So that thing there on number 6, I said find the best guess. That's what I meant. Yeah. But you can say find the best guess using Spencer's hack within parentheses, so that people remember. Find the best guess using Spencer's hack, and then we'll take and the corresponding player to the next line, right? Yeah. Everybody understand what Spencer's hack was? I assume. Yeah. Okay. That's the least difference from the target. Okay, and the corresponding player. Okay, that's all. Everybody okay with this? Yeah, I'll take a break. Maybe I'll grab a drink of water and come back in 5 or 10 minutes. I think we have enough time. Yes? 5 or 10 minutes. Do as much as you can. If you get stuck, ask me. Yeah? Anyone? Really, to help? And we'll... Brian? And call out the code. And Brian, you got to be alert now, because people could call out code and you got to type it in. Yeah, you should all feel free to call out code for Brian to type in, because he's maintaining this thing here. Okay, so when you guys have got a good idea, or let's say Kiara has finished one part of it, let's say number 1 or 0, number 0, number 1. Okay, and she said, all right, I'm done with 1, and people at this table are okay with this. Can I call out the code and Brian can put it in? Right, first person to call out, that's the module that goes in. All right, maybe after that Roger says, okay, I've done number 2, right, and then he calls it out, Brian. So we have like a potluck program today with many people. But it'll be fun because we're all following the same plan. Is that okay with everybody? And it includes the online people too, right? Because you can talk and you can use a chat, because I know there's messages in chat. We're not checking chat. So talk and just grab Brian's attention. And you're okay with just typing in, right? Yeah, you can also do your own too if you want, but otherwise that's fine. Okay, all right, good. If everybody's okay with this, I'm gonna take a walk and grab a water, drink of water, and come back. Is that okay? Yeah. What time is it now? You have about half hour at least.
40 minutes.
Yeah, we got a lot of time. All right, hey, online guys, everybody okay? Everybody okay? Ong, you're online today? All right. Is anyone trying to say anything at all? Justin, your lips are moving. I can't hear you. No, you're not. All right. All right. Okay. All right. Ong, you're not. Ong, are you here?
Oh, yes, I am.
Okay. All right. Okay. Good. Excellent. All right. If you don't have any questions for me, I'm going to take off and I'll be back in like 5 or 10 minutes. Hopefully, when I come back, I want to look at this code, and you should have at least the 0 part and the web point in the first few bullets, right? Someone should have completed it and called out the code for Brian to type it in. Yeah. Okay. Good. Thank you. Right, and so I'm just going to be hanging around until then. I'll get some water and come back. Hey, Chris, That's fine. Yeah. Oh, yeah. We can talk now because after class. So. No one's done anything yet. So one of the options is that you can also take this home. We can say, well, end class sooner, so that you can go home and relax a bit and then come back to this. But hopefully, by the end of today or maybe tomorrow, you should have something interesting done, right? The only risk of saying, well, you can take this home, we can end class now, is that you'll forget about it after you go home, because you have other assignments to do, a lot more distractions. So it's up to you guys. If you want to take it home, and if you feel comfortable with, I'm confident that after dinner, maybe, right? After dinner, when the rest of the family is sitting down watching a show, right? If you're confident saying, well, let them do it, but I'm going to be in my room, hold up and with my computer. So if you're confident of that, fine. You just go home. I'm okay with that. My only what I look for essentially is you doing it, okay? And look at it, right now I'm here in the capacity of a policeman, really, because the problem is out there. And what am I doing? I'm not teaching you anything, and I've told you this is what you got to do, and I don't want to walk around with a stick and saying, oh, you're already doing it. Yeah, so you got to do it, or you can, and if it means that you have to go home, that's okay with me. I'm not ranting, okay? That's important for you to know. I'm not ranting, but I want to make sure that you're aware of all the options. So you shouldn't feel obliged to stay in class only because I'm here and I have, this participation point thing and so on, okay? Really, for me, as far as I'm concerned, I say this to the online students too, right? So the participation points thing and the mandatory nature of this class and all is just a way for me to increase the likelihood that more of you will get these points. Because if I said, no mandatory class, most of you will be absent, which means, I can't really drop you, but you're going to take a hit in your participation points. And also, this is the thing I'm going to make sure, I review your code, right? One sec, Raj. Okay, I'll remember. Okay, but I can tell when someone just quests like one day before the freeze date, then I know that they're not trying to understand things. They just get the solution from somewhere and pass through, eke through, right? So if you tell when someone is actually trying to understand a concept, when you see consistent effort over a period of time, not just in the last couple of days before something is due, then they're doing, get over with it, right? But get over with it doesn't make a software engineer. Yeah. So you got to be interested in the problem, so you solve it all the way through. And I can look at it, right? I can look at it in painstaking detail. Like I said before, in the previous days, in the olden days, I used to wait until, every assignment end of the week, that's when it's due, Thursday or Friday, something like that. And I would wait to get all the things and look at the code. But now I can just go anytime and I can get the instant lay of the land, right? So I can tell. And I can, generate simple Python scripts, right? And it'll generate a report for me saying, well, this student was only active, to draw a plot, right, of the days when they're active, or compare with free states. You can tell, right, when the activity peaks. And, but those are the important things, flags that you should watch out for, I think, because participation points, even though it's supposed to be subjective, it is not totally subjective, okay? It is objective to a great deal. And I look at data like this. And I can't say, I think this is a great person. He's done a lot of work in class. Yeah, okay. I may have a personal liking for a certain kind of interaction, but at the end of the day, if the data says otherwise, then I got to overrule that and say, well, it hasn't been participation, and all the other students are being graded the same way, right? So, and people always email me in the last week and say, can you can I do something else for participation? No, you can't do that. Okay, you got to do it right now. Hey, Raj, thank you.
I just tried generating a bunch of random integers, but I got some stuff in Hex.
Oh, in Hex?
Yeah.
Why don't you hang on just a second, Brian? You're going to come back to you. Right? Can you share your screen and then we'll take a look at that and then we'll come back. Online guys, okay with that? I'm not getting any responses from the online guys. All right. Well, Eric is the only one who's giving me a thumbs up. All right, Ben too. You should speak up, okay? Because I can't. Have you shared your screen?
No.
Brian, can you? Yeah. Oh, I see. All right. Good. All right. So I think that the reason he got a hexadecimal number, and it's very good. Thank you, Raj. This is the second time. This is the first time was about the reference parameter or something. You asked a question. And it was actually you said, why are you putting the ampersand suddenly work? Yeah, this is reference parameters. This is a very important concept. And this too is a very important concept. And I'm glad Raj brought this up, because what he's doing there is doing what I think is a Python way of doing things. Output an array and it'll print the whole array nicely formatted. Yes, in many languages. As a freebie, you don't get in C++. Okay, if you want to print an array, you got to go and do it yourself. Okay, if you say print, what happens when you print the whole array? It's kind of crazy, isn't it? You say I print the whole array in C and C++. What happens is an array is just an alias for a memory address. That's what I said, right? When you said, give me random ints, 80 bytes, and random ints is the address of the first byte, and that's that hexadecimal number. So in fact, how many bytes is that? 8 bytes, yes?
Yeah.
This is a 64-bit computer, right? So that's a 64-bit Mac, yes? So, 64 bits is 8 bytes, and so that's, 16 hexadecimal digits. So it's a memory address where the 80 bytes start in RAM. It's out there. Yes, Jonah?
This program also shouldn't work because you said random ints I equals rand, and that shouldn't give.
Oh, yes. Yeah, maybe. Well, he wasn't getting. I think he was getting there. You haven't done the percent 1,000 yet. Yeah.
You want me to do a modulus?
Yeah. Percent 1,000. Is that what you meant?
Yeah.
Yeah. Right, but even then, it's going to give that big ass hexadecimal number. Yeah, because it's printing random ints, which is just an address. And so that is both the power and the ugliness of native arrays. So in order to do this, what you have to do is iterate from 0 to 9, and 0 to less than 10, and then print out set width, right? So I'm going to do this, okay? I'm going to do this part. So no, not there, not no, just yeah, right. You're assigning, right? You can get rid of the braces and all because it's just one line. Yeah, right. Okay, all right. So on the next line, you're going to say instead of your C out, you're going to just say 4, 4, and also say size t. For size t, I equals 0, I less than 10. Size t, and even the first int should be for size t. Yeah, size t, I equals 0, I less than 10. Yeah, I less than 10. I plus plus. Right, and then you can do a C out. C out. C out. Oh no, set width 6. Okay, let's say set width 10. No, it's 10 times 10, 10, 20, the 100 columns. Let's say set width 6, right? 60 columns. Okay, set width 6, set width 6. No, set W, and then parentheses 6. Someone said check the Google or something, right? What is the syntax for set W in C++? I think that's what it is. Yeah, I think it's set W. Example, set W6. Yeah, okay, that's what it is. That's good. So you can go back to our tab and then say set W6 and then left shift. Left shift after the set W, left shift. Yeah, and then rand underscore ints. Oh, it's a random ints. I see. Square bracket I, and then put a space just in case it's oh, it can be put a space after that. Put a space. Left shift space. Left shift space. Left shift. Just a space. No, you had it right at the end. It's just space within a quote. So I see space within a quote.
Oh, I see.
Yeah. All right. Now semicolon after that, and after the for loop, you're just going to print an end L. Okay. Print an end L. Now this is actually a digression from what we tried. I think right. We were going to do something else. All right. So now hang on. Oh, set width. I think you have to include. Go to the top. Right. So
Getter, setter.
No. Get set width uses IO stream standard lib vector. Oh no. It says std double colon s set w. Right. Right at the no. You're using namespace standard. Go to the bottom again. No, get rid of the cout random ints first. Okay, we don't need that anymore. Right. Set width 6. Random ints of I. And then a new line. You need a cout endl, because you wouldn't need an endl at the end, otherwise it won't flush. But why is it giving you no, not there. At the next line, you'll see why. Because on that line you don't want any endls. You want number space,
Right.
nicely formatted. Yeah. Right. So and then that is not part of the for loop. So you push it out, push it back. All right. Now why is set width? Why is set w not working?
Well, saying, did you mean get width?
No.
It's not declared in scope. Why do we
Look at the example on the other tab. Just look at the example for sans. Yeah. How are they? IO manip. Okay, sorry. This is I done this so many times I still forgot. Yeah, just call hash include IO manip, IO manipulation, and put it after IO stream so that you group all the include files nicely. And then put a blank line after that. Oh no, yeah, that's fine. Okay. All right, now if you run it, I think it'll run now, right? All right. So wait, no, they're supposed to be floats.
You want it to be like 0.0?
No, they're supposed to be floats, right?
Well, did we do size t?
No. Size t is the index I. Random ints of I. Random ints is a float. Oh, size t random. Oh, random ints. Oh, you want to print the average. Oh, I see. No, that's fine. I thought you were printing player guesses. They're floats. Yeah. All right, this is fine. You random ints. Good. Size t. Sorry, Roger. That's what you're trying to say. I got confused because I thought we were playing with the guesses now. Everybody okay? Right. That's the first part, isn't it? That's 2 bullets already. 2 bullets. Jonah, you got a question?
Yeah, so I'm having trouble with something. I'm trying to use the size function, the dot size function on the
Vector?
array, on the size t.
No, you can't. It's a native type. It's an address. You can't addresses don't have methods.
How do I find the size?
All right, okay. Fantastic question. How do you find the size? That is one of the drawbacks of a native array, but it's also, it's great. Okay. How do you find the size of an array, a native array that's, that you've declared out there, but you don't know what the index is? Okay. How do you find it? It's a challenge. Okay. Yeah, Raj, yes.
You just do size of your array and then divide it by size of the type of.
Yes, yes, thank you. All right, okay. So that is the only way you can do it. You got to take the size of the randians, and it'll tell you it's 80 bytes, okay? And then take the size of randians of 0. Well, actually, you shouldn't say randians of 0 because it could be 0. I've seen lots of programmers do that, okay? Even professionals. They say size of divided by size of the first element when they don't know if there's a first element. Yeah. So what you should do is size of the thing divided by size of whatever the type is, size of size t, right? And that'll give you the size of the array. It's kind of convoluted, isn't it? So, but you got to get used to it. So it has a little bit of ugliness in C++, I think, but I love it, right? Despite all of that, because yeah, it's nice. Once you get used to it, maybe, okay? Once you get used to it, it's these kinds of things are cool. You can discuss this in the forums, okay? Discuss in the forums. So how do you find the size of an array? In fact, I never asked that question in any of the specs. In the specs, I put footnotes and interesting questions at the end, usually, but I should have asked this question. So how do you find the size of a native array? I think it's because we never use a native array in any of the specs. In all of the specs, we just concentrated the algorithms and went directly to a vector. But native array is more like C. We're doing C, not C++. But you should absolutely learn about it too. In the syllabus, it's there. So you should. Good
Professor?
Thank you. Thank you.
Professor,
Yeah.
I finished the program if you want to.
Oh, you finished the whole thing?
That.
Okay,
Yeah.
all right, okay. But say, hey, Ben, but no, not yet. Okay, hang on to it. We're going to say before. What time is it now? Right, in the last 5 minutes, if nobody else has anything to do, anything to show, then we're going to go for. Well, even then, we're going to still look at Brian's program, but it's going to be in the last 5 minutes. Before that, because I know he's got a working program at this point. Anyone who says I've got it working, they should go at the end because very strong chance that others will be influenced. Okay. Hey Ben, hang on to your code. Okay, we'll still demo it, but at the end. Anybody else? Hey, take the screen, Brian, and then you can type in the code that I don't know, maybe Raj. So you got the first 2 bullets. Finish the first 2 bullets, and then we'll come back to this. Okay. And last 5 or 10 minutes, let me know. So we actually look at the whole program by Ben. And that's not going to be the end of it. You're going to be taking, versions of the code, changing things here and there, and sharing it on Reddit. Okay. All right. So, hey, Raj, you want to call in number 0 to Brian, and then he'll type it in. Hey, put blank lines after that, 1 blank line after number 16, and then go to line number 32, and that's where you can start typing in, whatever that thing is for 0, and then for 1, and so on and so forth. Okay, let's do 0 first. Okay, so let's do item 0, and Raj is going to call out the code for item 0, and I will, we're all going to be here. We'll participate. Go to line number 32. Yeah, one more enter, indent in. Yeah. All right. Now this is the code for 0. Raj is going to call out the code, and Brian's going to type it in. Okay.
So it's for size t I equals 0, semicolon I less than 10, semicolon I plus plus. Enter an indent, yeah. Random underscore int. Square bracket I equals rand parentheses. You can do the percent or modulus after that. There you go. And then semicolon.
Oh, that was there already. What did you delete? What did you delete? Oh, you were coding it. You were coding. Oh, I see. Okay. All right. Yeah, you got it. All right. Okay. Now, number 1. Okay. Who wants to do number 1? Okay.
Wait, doesn't you have to do the second after that?
What is that?
Which is for size t I equals 0, like the set width 6 less.
No. So I think oh, I see. Print a message. Yeah. Okay. You can do that. If you want. Right. So if you want, what you can do now is print the prompt. How about this? Okay. What Raj is suggesting is, shall we do things out of order? That's okay. What the order here is, first calculate the average and store it in a variable, and then do all of that. Doesn't matter. You can calculate the average later too. So why don't we do the average calculation first, because it's simple and easy, no user interaction. Yeah. And then we'll, get it done with, and we can move it later. It's just 2 lines. You can move it here and there. Okay. So we're going to calculate the average on the blank line. Okay, yeah, and start a comment saying average calculation, and you're going to do this. Okay, someone do this. Someone do this. Okay, maybe someone from the other side. Okay, Juliana, Vivian, Rebecca, Kira. All right, someone from there. Maybe you're going to do the and Ian, you guys too. All right, so you're going to be doing one of the bullets after this. Okay, so do one of the bullets, and this one. You're going to calculate the average and call out the code, and Brian will type it in. Yeah. Okay. All right. So. All right. So. Someone from there is going to call out the code for calculating the average. Are you guys okay with this? Anyone? Anyone? Yeah, okay. All right. So yeah, so you're going to call out the code and then they'll calculate the average. But you want to make a double float variable, float average, and then you're going to float average equals 0, and then you're going to calculate. Oh no, float average, and then they'll call out the code for making the average calculation. Okay. All right. So go ahead. You can call out the code and then he'll type it in.
For average was inside the for loop.
Oh, nice.
And then average and then plus equals.
Yes.
Random is
Yes. All right. Thank you. Thank you so much. Yeah. That I like that. Okay. Thank you, Rebecca. Okay. I really like that because she did it differently to how I suggested. And this is actually much better. Everybody understand why this was better? Right? Because we don't have to do two separate passes through the loop. In one loop, she's getting the number and then calculating the average too. Yeah. So that is like super duper cool. Right. So yeah, when we're done with that, we'll go on to the next line. Okay. Oh, now you need braces and all? Yeah. Okay, just walk him through the whole code because, hey, Brian, you got to fix the braces and everything. It's got to be in. So we'll do that and then we'll come back. Okay, yeah, go ahead, Rebecca. Just fix up the rest of the code. Oh, is that it? Oh, but you got to have a variable called average and set it to 0 and all before you start, right? Because you're going to be adding into a random number. Yeah. Load. Nice. Oh, and you got to initialize it to 0. Otherwise, when you're adding stuff to it, is it right? Is that right? Okay. All right. So that is like super important. It worked because it's total chance. In C++, you can't take things like that for granted. Python maybe it initializes. Integers are not initialized in C++. And I've, even with professional people, it's not in the standard. Maybe it's in the standard. Someone needs to check and say, see, it is not the C++ way to initialize things. And so, and people always say, no, it works. It's right. It is being initialized, but you can't take a chance on this. Okay. Because C++ does not promise anything. Because why would it initialize it if it doesn't need initialization? Yeah, that is the power of C++. So yes, it worked by chance, and good thing we caught that. Okay, so always initialize explicitly. Thank you. All right, now that's not enough though. You guys, that is just the sum now. It is the sum of all the numbers. You need to calculate the average. That's not done yet. Yes.
Yeah, and then I guess
Yes, I think that's what it is. Yeah. At some point, you can generalize this to not have 10 as a magic number. You can say number of numbers and then have constant, and then you can change this right later on. Yeah, Raj.
Why do you call it average if it's gonna be divided by 10 later? Like, why don't you just call it sum?
One sec, okay? I'll get to your question in a sec, okay? Now, here's a shorthand that we're going to use. Do you want to use the shorthand? Divide equals? Yeah. All right. So yeah. And then a semicolon after, and then say 10.0. Yeah. Even though we know average is float, just in case we're dividing a sum of integers, we want to divide by a float to make sure the division happens in float space. Just defensive programming, okay? So when you're driving a car, you can get a license without still being an offensive driver. You do all the wrong things and unfriendly decisions on the road. Right? That's why you have a separate course called defensive driving. Defensive driving is when you drive, but you compensate for other people's mistakes. Right? It's a defensive. And so defensive programming is to say, well, it's not strictly necessary, but it's going to reduce the chances that someone else who's maintaining the code will make an error there. right? So even if they screw up something, this will prevent that from happening. So this is one of the things. 10.0 is, it's a very thing, you don't even notice this, but later on you will notice these things in code that you inherit from other people and all, right? So, all right, good. Enter, and enter. Is that it? You got the average now. Okay, yeah, Raj's question. Well, Raj said, why do we call it average if you're just adding it up, right? And yes, very good question, okay? In fact, what we should say, call it sum or total, and then say another variable called average equals total divided by 10.0. Yes? Okay, that would be the right thing to do. And in fact, if you can do that, I would like that, because it doesn't matter from the compiler's perspective. It'll optimize both of them into the same variable, because they're used in non-overlapping context. Right? If they have overlapping context, it can optimize them into the same register or same variable. So when you have non-overlapping context, it's a prime optimization candidate. Doesn't matter. The compiler will take care of it. So why don't we do this? Okay, it's just practice in programming. You can say create another variable, what Raj suggested, right? At the top, saying total, and then later on you can say, in this case, it will use different variables, because its total is going to be integer, and then your average is going to be integer divided by, in fact, it's better. Okay, yeah. So say total float, no, there's a size t total equals 0. And I'll say why this is better, okay? So total equals 0. And then you don't have to say if float average equals 0 anymore. Blank line after that, blank line after that. All right, so because average is now going to be explicitly set, it's not going to be added to, but we'll leave it like that, okay? Defensive. Now, yeah, total plus equals random insify. All right, now average equals total divided by 10.0. Okay, does that make sense? Now that'll make Raj a whole lot happier. Yes? Okay, yes, Raj, so that's what you were trying to say. Great. So we're just going total divided. Is everybody okay with this? So now we got the average. All right, now what is the next step? We got the average. Now we've got to print all the numbers. Okay, now I'm going to print all the numbers nicely formatted. Okay, and this is the part where set width and things come in. You're going to do that. Someone is going to call out the code, and Brian is going to type it in. So print out the numbers. Then you're going to sleep. Oh, no, you're going to print the prompt first. Print the prompt saying, see out, take a good look at the following numbers for the next 5 minutes or 5 seconds or something like that. You're going to print out the numbers, sleep for 5, print out lots of spaces, erase that. Can you all do that by yourself? Yes or no? 3, no, first print a prompt. See out a prompt. A prompt saying, watch, take a good look at the numbers below for 5 seconds. Something like that. You got to say that in a cout, endl after that. Next line, print all of the numbers, nicely spaced out like we did. And then a /r with a cout flush. So numbers show. And you're going to sleep for 5 seconds. And after you finish your sleep, you're going to print lots of spaces and a /n, endl. So the numbers disappear. Is it okay so far? Yes? Someone's going to call out the code and Brian is going to type it in. Now, after that, it's pretty straightforward. Yes? Because all you got to do is say, well, the numbers are gone now. What is the average? You're going to ask the players, give me a name. And if you don't have a blank name, give me the average guess too. And you use that and store it and find the best player and, announce the winner. That's all you got to do. And in fact, if you complete this program and post it on a, Ben's already done it. Everybody who posts a version of this program, it can even be the same as Ben's, with minor tweaks, that's fine. Okay. If you do that, it all counts for participation. Okay. You can call it extra credit, but it'll actually count for this week's participation, right? How about this? Especially if you interact with other people and say, with friends who are not even at my table. Okay. And or online and face-to-face students, and exchanging code and saying, well, this program completed uses, Raj's code here, Isidore's code here, right? Akira's code here. One program. All of you get credit for that program. Yeah, everybody whose name is on the program gets credit for that program. Okay, so how about this? This is really cool, isn't it? Rather than be bored about things that don't work, you'll be able to work together and interesting stuff, right? So I think it's a whole lot better than getting individual points. You're still getting the same points, but it'll be together work, more representative of the kind of work that you'll be doing later on eventually, right? Very rarely, other than for total noobs, very rarely you work in a silo. You're going to be working with other people and learning tips and techniques and working on their code too. So it's important to get comfortable with other people's code. That's one of the things that beginning programmers find difficult to do, is getting comfortable with other people's code, because they get to a certain style. I've worked with programmers who got irritated when someone else says, take I'm going to modify a program and change the style a little bit, and they get irritated. And so I don't like that. Okay, those are signs of being too possessive about your code. You should never be possessive about your code, anything material, right? This is the idea that matters. Okay, don't screw up the idea, and that's fine. People are not out there maliciously trying to screw up your idea. They're trying to do things, and so yeah, I think that is one of the ways in which you practice to work with other students in class. These are opportunities. I'm just, yeah, mildly disappointed that these opportunities are just going waste. You have an incredible opportunity. You have lots and lots of intelligent people in class. Everybody knows they're, are working hard. Well, maybe they're working on other courses too, but there are people that are certainly, everybody is totally capable of doing all these things, but you're not, okay? Because of demands maybe, but you got to make sure that if you want to major in computer science, you got to put yourself into it. Okay, and I'm pretty sure lots of you want to major in computer science. Okay, yeah, I used to have classes where lots of people from other departments just trying to get an idea of computer science. There was 8 a.m. classes. In 8 a.m. I used to get lots of students from English, art, history, in 2A level. But 6 p.m. I think lots of students are really interested in computer science. So I think I'm just going to say, you got to put yourself into it. Okay, reduce your other load. You can do that later. I'm not saying don't do it, but make sure you put a lot of time into this, because this will come back and pay back in big time, right? So yeah. Thank you. All right, Ben, what is, if nobody else, how about, all right, we're going to leave this program now. You guys are going to complete it and post different versions, maybe even together, okay? We'll go to Ben's demo. We'll take a look at Ben's code. Don't be influenced too much. Maybe, Ben, you don't have to show the code so much, right? So as to bias, because even if they have an idea of how to do things, well, I don't know, it's up to you guys. Okay. But I would suggest that we look at the behavior of Ben's program and then look at the comment, look at the code very briefly. Okay. Just maybe enough to get an idea of how to do it yourself. So, right. Great. Ben, take the screen and you can do a demo of your code. Okay. Oh, you're asking for the name. Oh, get a look. Oh, I see. You got to run it. You got to run it. I didn't see the numbers at all. Oh, you got a flush. You got a flush. What is it? You got a flush variable? You got a variable called flush? What is a variable called flush? Do you have a variable called flush? Well, flush is a system variable, is it? Is it because I can't hear Ben? It's totally weird. Why? I didn't know there was a
Oh,
system
sorry.
variable.
Can you hear me now?
I can hear you now.
Okay, awesome.
Oh, so flush is a standard variable?
Yes.
I see. And you're sure it does flush?
Yeah, I mean, we can run the program if you want to see it.
Yeah, I thought you ran it and we didn't see the numbers. I thought it
Oh,
was.
sorry. I just had already clicked run, but I can do it again.
All right. Okay, cool. Oh, there it is. All right. All right. I'm going to guess. Oh, geez. Oh, hey, not fair. Okay, run again. Run again. All right. I'm going to guess. Okay, I got it. I got it. I got my best. I got my guess. Okay. No, but before I tell you what my guess is, I'm going to say, I'll go last. Okay, I'll go last. I'll write my guess down so I don't change it based on you guys' guessing. Okay, so everybody take turns guessing. Give. All right. How about Isidore? Type in Isidore and take Isidore's guess, and I'm gonna write down my guess somewhere if I can find a marker. Hey, you're an awesome teacher. Rock on. Oh, it's for Jeff, but I'll take it. Here's my guess. Okay, I'm going to say. It doesn't write. Oh, it does write. Okay, my guess is right behind that eraser. Okay, I'm not going to change it. Isidore, what's yours?
The number is the mean of the number.
Yeah. Oh, you didn't see the numbers? Okay, how about this? Okay, hey, Ben, run again. Increase the font of the console. Increase the font of the console. Command plus or something like that, right?
How do I do that?
I think hit Command plus. Is this a Mac or a PC? It's a PC. Control plus. Yeah. There you go. Can everybody see the numbers? You should be able to see it on the screen. When he shares the screen, you should be able to see this. Right. So see the numbers, and my guess is not going to change, I think, right? So after he runs it, I'll make my guess. Everybody should make their own guesses. We're all going to play this game. Right?
Everyone
Right?
ready?
Yeah, ready. Wow. Okay. I'm going to change my guess. All right. Okay. Gee. Oh my gosh. Okay. Okay. All right. Okay. I got my guess. Unfortunately, you know what? Okay. Isidore, what is your guess? Oh, you know you can't calculate these things.
No, I didn't say. I'm just. It's still.
Okay.
I didn't remember all of the numbers. I'm just.
All right, go for your guess. Everybody go for your
Should I
guess.
write it down?
No, tell him what the guess is. Yeah, Isidore, what do you think your average is?
384.
All right, 384. Right, 384. All right. How about Chris? Chris, go ahead. Next. What is your name?
520.
520. Chris says 520.
It's around the 600.
Who said? Roger says 600 and what? 624. Roger says 624.
I say 655.
Okay, Jonah 655. I say 600.
727.
70. Oh, maybe 727 would be right. Yeah, because I saw a lot of numbers in the 700 range.
What did you guess? For
Yeah. Mine is 500. Mine is no 600. Minus 600.
Oh, now you're just 600. I thought you said 700.
No, I said 600.
I said 727.
Oh, he said 727. Yeah. Raj. How about, hey, Juliana, Rebecca, you guys don't have any guesses?
I was close to Raj. I was thinking like 700.
703. Okay. Right. Rebecca is 703. Juliana, you got a guess? Vivian, Kira? No? 570. Kira says 570. Yeah, I'm playing, I'm like running housey here.
570.
All right. Hey, Caesar, you guys have any guesses?
570.
570. Okay.
The same.
Hmm?
Yeah, the same.
No, did someone else say 570?
Yeah, it's now.
How do you spell Caesar?
Oh, CAESAR. Actually, I
What
think
was
it's
their guess?
CESAR, is it? It's just CESAR. Yeah.
whatever.
No, I spelled the Roman Caesar. All right, okay. So, what is the average, Caesar? 620. And you said 507?
Maybe
550. All right, 550. Jink, is it? How do you spell your name? Junke. Q. I thought it was a QE. No, K.
What was their guess?
570. Is that right? That's what you.
550.
Oh, he said 550. It's actually pretty exciting, We're actually looking for who's gonna win. Yeah. All right. Okay, we can. Is everybody got a chance to guess, or anybody wants to go and right? Panini and Simon, if you want, you can Ian, and Vivian also. 1, 2, 3. All right. So yeah, Ian says EAN. Wow. Okay. 1, 2, 3. Okay. Juliana. 737. Right, nobody online. Kaden, Kaden Ong, you guys don't want to take a guess? Akash,
I'll take one.
who is this? Eric,
Oh,
Eric.
yeah,
Yeah, Eric.
452.
452. All right, is that it? If nobody else has any guesses, he's going to hit enter, and we'll see the winner.
Can I
That's
try?
really cool.
Can I?
All right, so if any of you know Swift, here's my
Right.
offer, extra credit project. If you know Swift, I will guide you into building an iOS app, which you can release in the App Store, which turns this game into an iOS game with bells and whistles. all the numbers will be in nice fonts. It'll be show up, and I mean, we can do all the nice things so that it looks really cool. We can do an iOS app if you know Swift. This is the same algorithm, right? It's gonna be fun, and you can make it, make lots of changes into it too. It's extra credit, obviously. You can do, this, and then you can do variations, and you can even have, if it's an iOS app, you can have flags and say, oh yeah, I want to play this variation of it. I want to play, guess a sonnet. It's all the same, right? Everything is the same. So you could try this, okay? So how about we want to do the enter? Oh, Justin's got a guess.
Can I get 521?
521, okay. All right. Are we ready to go? All right, so 7:52. Let's find out who the winner is. I'm actually, hey, Punny, you want to go? No, too late.
You, Professor.
Wow.
Wow, look at that. All right, that like total fluke. Okay, but what was it? What did I say?
It was 600. It was 600.
It was round 600 round.
I think 609.2. 609. I got 610.
That is so cool. That is so cool. I had no idea. The first batch of numbers, I wrote 500. I wrote 500 here. But it's actually pretty cool, isn't it? It's pretty cool, isn't it? It's an actually engaging game. So you can do this. You can play this game with your relatives at home, and other people. Share your experiences with this game on the Reddit, right? Share versions of this game. And if any of you are interested in the extra credit project and you have a little bit of Swift knowledge, you don't have to know all. I can show you the basic things. I used to do. I did Swift a long time ago. But I don't think it's changed all that much. It's changed a lot, right? But I'm pretty sure that if you're familiar with Swift, I can basically, guide you. I'll be happy to do that. Turn into an iOS app. And it'll be fun. You can actually have people across the world playing your memory game. Not a memory game, but yeah. You can make it one, because it can actually be helpful in old age homes and all, right? Where, people are trying to do Sudoku and things like that to keep their memory sharp. Right? This is going to be a game, a cognitive maintenance game. Yeah. So all of these, and we can, do the iOS app in such a way that it's positioned like that. Sharpen your memory. Yeah, you can totally do it on Android. Yeah, you can do it on Android. Yeah. No. You can do it in Android and Java.
Okay.
Yeah. Same thing you can do in Java. I can help you. Yeah. But Android development is more of a pain for me. Huh? Oh, why don't you do it in Android and I can watch you even, right? I can watch you
I
or
don't have too much experience with Java.
with what?
I don't have too much experience with Java.
With I know Android is all in Java, right?
I think so, yeah.
Yeah, it's very much like C++. I can help you with Java.
Sure.
Yeah, anything to do with Java, I can help you.
Thank you.
Okay. Everybody happy? Yeah. All right. Okay. Cool. I'm going to close the meeting. Hey, thank you guys. Okay.